Today we're going to focus on doing elimination when we do not have a coefficient that's the same. So on the last worksheet we worked on, all of the problems had at least one coefficient that was the same. The x's were both 2's, or the y coefficient was both 7, or something like that. In this particular problem, and in all the problems you'll see on today's worksheet, the leading coefficients, or the x coefficients or y coefficients, will not be the same. So if you look at this problem here, your x coefficient is 2 here, and your x coefficient down here is 1. Remember, if there's no coefficient, the coefficient is 1. On the top one on this side, the y coefficient is 7, and on the bottom one, the y coefficient is 3. Now I want to pay specific attention again to the fact that I didn't care if they were positive or negative. I didn't say negative 2 and 1 and 7 and negative 3. I don't care if the coefficients are positive or negative. All I care is that they're the same number. Now because they're not the same number, I'm going to have to turn them into the same number by multiplying. This works a lot like finding a common denominator. We're looking for a common denominator between numbers 2 and 1, or between the numbers 7 and 3. So if they were denominators, if this was something over 2 and something over 1, and this was something over 7 and something over 3, what would the common denominators be? That's what I'm asking myself. And it's called finding a common coefficient. That's what this process is called. So we're going to find the common coefficient between negative 2 and 1, between 2 and 1. And the common coefficient there would be 2. And then we want to find the common coefficient between 7 and 3, which would be 21. Now, Mr. P uses the path of least resistance usually. I see that 2 and 1 are going to give me a smaller number than 7 and 3 are going to give me. But I don't always just look at the number they're going to give me. I also look at the signs. I like it when the signs are not the same. I like it when the signs are opposite, because opposite signs mean that in the future I'm going to add rather than subtract, and adding is usually easier than subtracting. But in this case, both signs are opposite on both coefficients, so I'm going to go with the smaller of the two numbers, which is 2. So I'm going to do negative 2. I'm going to change it to 2, well it already is, so I leave that top one alone. Negative 2x plus 7y is 10. That one's good. But the bottom one needs to be multiplied. And we ask ourselves, what do we need to multiply 1 by to get it to 2? Well, we need to multiply it by 2. But not just to the 1, to this entire equation. So 2x times 1x is 2x. 2x times negative 3y is negative 6y, and 2x times negative 3 is negative 6. Make sure you keep your equal sign where it belongs. Now we can go through the elimination process. So our elimination process says same signs, subtract, different signs, add. So the signs are the same on our 2's, on the coefficient that we've made the same. That's where we're focusing, on those 2's. So we're going to add these two together. Negative 2x plus 2x is 0x. You can write that down or just leave it out of the problem. Those x's are gone. They've been eliminated. 7y plus negative 6y is 1y, and 10 plus negative 6 is 4. So we now know that y is 4. That doesn't complete our problem, but it gives us the y value. Now that we know that y is 4, we need to come back and find x. Mr. P always uses the top equation so that he can stay consistent. So I have negative 2x plus 7 times 4 equals 10. 7 times 4 is 28. Negative 2x plus 28 equals 10. I will subtract my 28 from both sides. Negative 2x equals negative 18. Divide by negative 2. Divide by negative 2. And x is 9. So I end up with the final answer 9, 9.